Hello everybody. Last time we have discussed about topic on partial differentiation. Let us quickly revise the topic's name. First we have seen about function, then graph of the function, level curves and level surfaces, and limit of the function, and then finally we have discussed about the continuity. Let us quickly revise the topic on the paper. Let us see on Teletop. We know that function is a rule connecting two sets A and B such that every member of X that exists unique Y belongs to B. So this is the function. A is called domain of the function. Domain of the function. If A is single real numbers, then it is function of one variable. If A is a set of ordered pair, then this function f is of two variables. If the domain of the function is a triplet, then we can say that function is of three variable, and if the domain of the function is of n variable, then we can say that function is of n variable. Then we have discussed the graph of the function. Graph of the function, the set of points x fx, set of points x fx is called the graph of y is equal to fx. Then we come to the level curves, the set of all points xy such that f of xy is equal to c is called level curve of the function. Then the limit of the function. Limit of the function is suppose y is equal to fx is the function, then we say that limit of fx as x tends to a is equal to L if for given epsilon greater than 0 there exists delta greater than 0 such that fx absolute value of fx minus L less than epsilon when absolute value of x minus a less than delta. If the function is of two variable, then we can say that limit of f of xy as xy tends to ab it is equal to L if for given epsilon greater than 0 there exists delta greater than 0 such that absolute value of f of x comma y minus L less than epsilon when square root of x minus a square plus y minus b square less than delta. So this is the limit of the function. Then similarly we can define the limit for function of n variable also. Now continuity of the function. Continuity of the function y is equal to fx is said to be continuous at x is equal to a if three conditions are satisfied. First, the value of the function at a is defined. Then second, limit of the function at x tends to a exists and it is a finite value. And the third condition is limit of the function at a is value of the function. Similarly, we can discuss the continuity of function of two variable let y u is equal to f of xy is a function of two variables, then we say that function f of xy is said to be continuous at x comma y is equal to ab points, a comma b. If three conditions are satisfied, function's value is defined. Then second, limit of the function f of xy at AB point is exist and finite. And third, limit of the function is the value of the function. So these are the ideas what we have discussed in the last time. Now we come to the partial derivative. Let us see on the slide a function presentation. Let z is equal to f of xy be a function of two variables. Then the partial derivative of z with respect to x is denoted as del z by del x or del f by del x or fx at xy, and it is defined as limit of h tends to 0 for the f of x plus h comma y minus f of xy upon h, provided this limit exists. Similarly, we can define partial derivative of z with respect to y. Let us write on the paper using TallyTop. Partial derivative of z is equal to f of xy is denoted as del z by del y or del f by del y or fy at the point xy, and is defined as del z by del y is equal to limit of f of x comma y plus k minus f of x comma y upon k as k tends to 0, provided this limit exists. So these are the first order partial derivative. If we have the function z is equal to f of xy, then we can find partial derivative of z with respect to x. So it is called del f by del x, or with respect to y, we call it del f by del y. These are first order partial derivative. We can further apply the idea of partial derivative for the function of n variable, and we can distinguish two cases: function of one variable and function of one variable. And function of more than one variable. If the function of one variable is differentiated, then function of one variable is differentiated, then we call it derivative. Of the function, and notation is d by dx. If the function of more than one variable is differentiated, then we call it partial differentiation, and its result is called partial derivative. Partial derivative. And instead of d, we use del by del x. if we are differentiating it partially with respect to x. In case of partial differentiation of the function of more than one variable, with respect to any of its variable, the remaining variable are treated as constant. So all the rules of differentiation can be applied for the partial differentiation. Let us see some example on the paper. First example, find the partial derivative of del z by del x and del z by del y at 3, -4 for the function f of xy is equal to x cube plus x square y plus 2xy square minus 3. So clearly, if we want to obtain the partial derivative del z by del x, then we have to differentiate this. Differentiating partially with respect to x. So we can say that del z by del x or del f by del x. So partial derivative of x with respect to x cube is with respect to x cube is 3x square plus 2xy plus 2y square, and derivative of 3 is 0. Now we take del f by del x or del z by del x at the point 3, -4. So we have to substitute x is equal to 3 and y is equal to 4. So 3 into 3 square plus 2 into 3 into -4 plus 2 into -4 square. So the value is this is 27, this is 6, 6 into 4, so 6 into -4, so it is 24, and this is 2 into 16, so we get 24 minus 27 minus 24 plus 32, so we get 35. Now suppose this is the result number 1, or this function is denoted as equation 1, then we can find the partial derivative of z with respect to y. So differentiating 1 partially with respect to y. So del z by del y is equal to derivative of x cube with respect to y is 0. Here x square is a constant for a while, derivative of y is 1, then 2x is constant, and derivative of y square is 2y, derivative of 3 is 0. So we get del z by del y is equal to x square plus 4xy, and del z by del y at the point 3, -4 is obtained as 3 square plus 4 times 3 into -4. So we get 9 minus 48. So we get minus 39. Z is equal to sine xy, then del z by del x is equal to, here this is function of x, this is function of x, so we have to apply u into v rule, which is, if u into v rule is given as u dash v plus uv dash for derivative. So del z by del x, we keep sine xy fixed and derivative of x is 1 plus x is fixed and derivative of sine is cos xy into derivative of xy is y. So we get del z by del x as sine x y plus x into xy into cos xy. Similarly, we can differentiate z function, which is given as sine x into sine xy with respect to y. So differentiating z partially with respect to y. So here we don't need to apply u into v rule because this is, the y is at one place only. So del z by del y is equal to x, derivative of sine is cos xy, into derivative of y is 1 but x is constant, so multiplied by x. So our result is x square cos xy. Now we can define higher order partial derivative. Let us see it in the presentation. From this above example, it is easy to observe that if f of xy is a function of two variables, then the partial derivative fx of xy and fy of xy are again function of two variables. So we can differentiate each with respect to x as well as with respect to y. So we see higher order derivative on the paper. Z is a function given as f of xy. Its partial derivative are del z by del x or fx of xy, and del z by del y is equal to fy at xy. Clearly, these both are the functions of x, so we can differentiate it. This del z by del x can be differentiated with respect to x, so we can take del by del x of del z by del x, which is simply becomes del square z by del x square, and it is defined as limit of fx of x plus h comma y minus f of xy upon h as h tends to 0. Similarly, we can find the partial derivative of del z by del y with respect to x. So del z by del y is our function and we want to differentiate it partially with respect to x. So we can say del square z by del x del y, it is equal to limit of f of fy of x plus h comma y minus f of xy fy, here fx was there, it was typing error, fy xy upon h as h tends to 0. Similarly, we can define partial derivative del square z by del y square And if we have the function del z by del y, we can again differentiate it partially with respect to x. So it becomes del square z by del x del y. Now let us, these are called second order partial derivative. So suppose we have the function f of xy, then we can differentiate it partially with respect to x with respect to y. So f of xy, if we have function f of xy, we can differentiate it partially with respect to x with respect to y. If f of xy is differentiated with respect to x, we call it del f by del x. And this f of xy is differentiated partially with respect to y, then we can say that del f by del y. Again, these two are function of two variables, so they can be differentiated partially with respect to x as well as y. Here del f by del x is taken first, and we again differentiate it with respect to x, so this becomes del square f by del x square. And here del f by del x is taken first, partial differentiation of f with respect to x is taken first, and then we differentiate it partially with respect to y, so del by del y, which is del square f by del y del x. So whenever we look at this, we have to start from the right side and come towards the left. So this way we can say. Similarly, del f by del y is differentiated with respect to x and y, then we get del square f by del x by del y and del square f by del y square. We can see in future next study that this del square f by del square f by del x del y is same as del square f by del y del x. But before that, we take some examples. If u is equal to log tan x plus tan y plus tan z, then to show del u by del x plus del u by del y plus del u by del z multiplied by, first we have to find this value, and then to prove sin 2x into del u by del x plus sin 2y into del u by del y plus sin 2z into del u by del z. For this, we need to find partial derivative of u with respect to x, with respect to y, and with respect to z. So we start from the given function. U is equal to log tan x plus tan y plus tan z. This is given. Differentiating this partially with respect to x. So we get del u by del x is equal to derivative of logarithm something is 1 upon tan x plus tan y plus tan z multiplied by derivative of tan x is sec square x derivative of tan y with respect to x is 0 and derivative of tan z with respect to x is 0. So this is the del u by del x. Similarly, we can get del u by del y as sec square y divided by tan x plus tan y plus tan z. And we can also find del u by del z as sec square z upon tan x plus tan y plus tan z. Now we substitute the value of del u by del x, del u by del y, del u by del z as in the first result. So del u by del x plus del u by del y plus del u by del z is equal to 1 upon tan x plus tan y plus tan z is the common factor, and the remaining is sec square x plus sec square y plus sec square z. So this is the value of the first result, and now we have to find this value as to find sin 2x into del u by del x, sin 2y into del u by del y plus sin 2z into del u by del z. It is equal to sin 2x is 2 sin x cos x. Value of del u by del x is sec square x upon tan x plus tan y plus tan z. Here again we have to find the value, substitute the value of sin 2y. So sin 2y is 2 sin x into cos x, and del u by del y is sec square y, which is 1 upon cos square y, and upon tan x plus tan y plus tan z plus 2 sin 2z is 2 sin z cos z, and the value of del u by del z is sec square z upon tan x plus tan y plus tan z. So we can, sec square x is cancelled with cos x, so 1 upon cos x will remain, so 2 sin x upon cos x, or I can take 1 upon tan x plus tan y plus tan z common, tan x plus tan y plus tan z common, then this 2 sin x cos x and sec square x is 1 upon cos square x, then this 2 sin x sin y cos y into 1 upon cos square y plus 2 sin z cos z into 1 upon cos square z. So we get 1 upon tan x plus tan y plus tan z multiplied to this cos square is cancelled with this cos, so we get 1 upon cos, and sin x upon cos x is tan x, so 2 tan x plus 2 tan y plus 2 tan z. So 2 is common, so 10x plus 10y plus 10z is cancelled with this, so ultimately we get the answer 2. So we have to show that sine 2x multiplied by sine u del u by del x plus sine 2y into del u by del y plus sine 2z into del u by del z is equal to 2. So this is our first example. Let us take another example. If u is equal to x minus y into y minus z into z minus x is given, then we have to prove that del u by del x plus del u by del y plus del u by del z is equal to 0. So proof, let us solve this. Here u is equal to x minus y into y minus z into z minus x is given. So differentiating u partially with respect to x, so del u by del x is equal to, here y minus z is constant when we are differentiating it partially with respect to x, so I keep y minus z fixed, and then differentiation of x minus y and z minus x can be found with the help of u into v rule, which is for derivative is u dash v plus uv dash. So derivative of x minus y with respect to x is 1 and z minus x is fixed for that term, then plus x minus is fixed, x minus y is fixed, and derivative of z minus x with respect to x is minus 1. Okay, then suppose this is the result number 1, then again we differentiate 1 partially with respect to y, so del u by del y. So here z minus x is constant when we differentiating with respect to y, so here derivative of x minus y is minus 1, y minus z is as it is, plus x minus y as it is, and derivative of y minus z with respect to y is 1, so we get this. Similarly, we can find del u by del z. So del u by del z is equal to, here x minus y is constant and we have to differentiate y minus z multiplied by z minus x with respect to z. So derivative of first term is minus 1, second term as it is, plus y minus z as it is, and derivative of z minus x with respect to z is 1. Now we add this 3, del u by del x plus del u by del y plus del u by del z. Now here we can get y minus z into z minus x, then minus y minus z into z minus x, plus del u by del y is z minus x into minus y minus z. So this plus sign will turn into minus. So minus plus z minus x multiplied by x minus y, and the last one plus x minus y multiplied by y minus z minus this and this are multiplied, so we get x minus y into z minus x. So we can check this y minus z into z minus x is plus sign, and this z minus x, this is minus sign, so they will cancel with each other. Here y minus z and z minus x is cancelled with this, and these two will be cancelled out. Okay, so ultimately we get 0. If u is equal to e to the power x y z, then we have to find del cube u by del x del y del z is equal to e to the power x y z into 1 plus 3xyz plus x square y square z square. This example. So we have to differentiate u function with respect to z first, then with respect to y, and then with respect to x. So here u is equal to e to the power x y z. So differentiating u partially with respect to x, so we get del u by del z. We are differentiating u with respect to z, so we get del u by del z, which is e to the power x y z into xy. So again differentiating partially with respect to y, so we get del square u by del y del z. So here terms of y is there, and here terms of y is there, so function are there, so we can use product rule for derivative. So derivative of e to the power x y z is e to the power x y z into x z, and this x y is there, so we can write e to the power x y z into, okay, we have to differentiate this with respect to y also, so e raised to x y z plus this e to the power x y z into x. So we get the simplification e to the power x y z into x square y z plus x. So this is our second order partial derivative, del square u by del y del z. So e to the power x y z is equal to x square y z plus x. Again differentiating with respect to y, so with respect to x, so del cube u by del x del y del z is equal to e to the power x y z into derivative of this x y z with respect to x is y z, and this is fixed, x square y z plus x, plus e to the power x y z is fixed, and derivative of x square y z plus x is 2xyz plus 1. So we simplify this by taking common factor e to the power x y z, then we can say that y z is multiplied by x square yz, so we get x square y square z square plus xyz plus 2xyz plus 1. So finally we get e to the power xyz is equal to 1 plus 3xyz plus x square y square z square. So this example is proved. We conclude our lecture by taking f of xy as a function of two variables. We can differentiate it partially with respect to x as well as with respect to y. Again, both partial derivative del f by del x and del f by del y are functions of x and y, so we can again differentiate them with respect to x and y. So these are the second order partial derivative. Today we have studied about the function and its partial derivative. If function is of two variable, then we can differentiate it with respect to x as well as with respect to y. So if function of xy is differentiated with respect to x, then we can say that it's first order partial derivative, and first order partial derivative is differentiated with respect to its variable, then we can get second order partial derivative, and we have seen some example. Okay, thank you.